Here are the questions from page 273, a handful of questions that we had for homework. I wanted to go over and just kind of give you an overview of each one in case you were absent from class. But the first one was number 14. It was talking about dice, and it simply said that if you rolled a 1 or a 2, you won nothing. You won $0. But if you rolled a 3, 4, 5, or 6 on that die, you would win the difference. You would win the difference between your roll and $2. So if I rolled a 6, 6 minus 2 is 4, I'd win $4. And that's the way this problem gets done. So the idea is this. My probability of rolling a 1 is 1/6. For that matter, the probability of rolling any of these values is always 1 out of 6. This is a normal die, by the way, 1 out of 6. So it really comes down to being the idea of what do you win? Well, when you roll a 1 or a 2, you win $0. So 0 times 1/6 is 0. When you roll a 3, you will win $1 because 3 minus 2 is $1. 4 minus 2 is $2, and so on. So it's always going to be your 1/6, the probability of winning, multiplied by the value that you win. And you end up with these values that you would then add together. And that does come out to be $1.66. However, you had to pay $2 to play the game. Therefore, your net result or expected value is negative 33 cents. Not a fair game, but then again, not many games of chance, such as for casinos or carnivals or fairs, are fair games. They're trying to have an edge for the house because they are trying to make money. So, moving right along, number 15, lottery prizes, more lottery prizes. Again, there's two methods on this. I'll show you the first method that we've been using for the most part, and that is what you win multiplied by the probability of what you're going to win. 1 out of 1,000 tickets will win you $1,000, so that's going to be $1. 1 ticket out of 1,000 will win you $500. That's going to be 50 cents. There are 5 $100 tickets to win, so that's going to be 5 out of 1,000 tickets winning $100. And again, that is 50 cents. Now some people ask, oh, what's this about? Would you have to write it? For this method, I would say no, you wouldn't have to, but it is good to always look at, this is the scenario of what you win, this is the loss. Kind of make sure you approach or take care of all possibilities. And for the 993 tickets that are not winners, you're okay, you're going to lose, but you're going to win $0. So some people would say I wouldn't write that. I probably would. When you get your value, you get $2. Of course, you paid $3, so you actually are net negative $1 expected value, negative $1. When you go to method number 2, it is actually the same idea, but we are going to account for the $3 in all aspects. So for example, instead of winning $1,000, you really only win 997. Instead of winning 500, you really only win 497, and so on. This method, I think, requires you the most to remember that it also accounts for the 993 losing tickets where you lose your $3. So you need that in there to do that with this method, and that will come out to be exactly the negative $1, the same as if you did in method number 1. So either one will give you the same expected value. It's just however you like to see it done. All right, number 17. Very much more about gambling and lotteries. I have 2 parts to this problem. Part 1 is in green. If you pick the winning number, you pick the 1 out of 1,000 ways. If you ask where's the 1,000 come from, if I have 3 digits I have 0 through 9, that's 10 numbers to choose the first digit, 10 numbers to choose the second digit, and 10 numbers to choose the third digit. If you multiply them together, there's your 1,000 ways to choose 3 numbers. So 1 out of 1,000 is a winner. You're going to win $500. That's a 50 cent. You paid $1 to play, so it's a negative 50 cents expected value, and you're finished. For the second part that's in fuchsia or pink, this time they say, okay, pick your number, but you can box it. Meaning, if I were to pick 348, I would still win if it was 384 or 483. With 3 numbers, I have 6 ways I could win. 6 ways. That means 6 out of 1,000 ways to win, and I will win $80. Multiply them together, you got your 48 cents. You paid to play, though. You paid the buck. So you really have an expected value of negative 52 cents. And you're complete. Number 18, this is about the life insurance policy of a woman. She pays $360 a year. If she, and then when she dies, she gets $100,000. The key really to this problem is the fact that it says find the expected value for the insurance company. From the perspective of the insurance company, they stand to gain $360 if she lives and lose $100,000 if she dies. So looking at it that way, and they already gave us the fact that she lives is 0.99057. That's the probability she lives. That means that the probability she dies is 1 minus that, or 0.000943. Here comes the expected value. Again, this is all about the fact that the company gains or loses. They will gain 360 multiplied by the probability that she lives. They will lose $100,000 multiplied by the probability she dies. If you run it through the calculator, you come up with 359.66 minus 94.30 for a net result, a expected value for the company of 265.36. 265.36. That is the expected value. All right, keep on trucking. Last problem. This one's very, very much the same idea as the others. You only have 1 ticket that you can win $100,000. You have 2 tickets. That's essentially a 2 right here. 2 tickets out of 50,000 now for $10,000. 5 tickets. That's 5 out of 10,000 will be winners for $1,000, and so on. Do the multiplication, add them together, you get $2. As long as, because these were free, you're going to get that money, with the concept that you do need to send in your mailing. You're going to have a first class stamp. Your expected value would be $2 minus a first class stamp of 73 cents for $1.27. That is as of today, April 2025. I understand this number is going to go to 78 cents in July, so that would be even a smaller expected value. All right. Well, thanks for listening. Take care.